David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember you can adjust the playback speed to make it faster or slower as you like. Second, you can pause the video at any point to catch up on your notes or jot down some questions. Third, you can turn on the captions so you can read my words on the screen. All right, today's lesson is going to cover integrals and natural logs. So these are a little different. So I want to go ahead and start with a problem, this problem here. So we're taking the integral of 1 over x dx. Now you already have a rule that will do that. So what I want you to do, pause the video, flip back to your notes, and go ahead and take the integral of 1 over x, and then we'll get into this natural log stuff. Okay, so I realized that 1 over x is the same as x to the minus 1 power. And I do have a rule for differentiating this particular power. I'm going to use my integral power rule, and I get equals 1 over negative 1 plus 1 x to the negative 1 plus 1. Now here's where it gets a little weird. I have 1 over 0 times x to the 0. So let's look at this. X to the 0, no problem. That's 1. Anything to the 0 is 1. However, 1 over 0 is undefined. Mathematics runs away screaming from this problem. How many zeros are there in 1? How can you answer that? This is a problem. And in fact, we can't go here. So let's take a look at how this really works by a little bit of a journey back to when we took derivatives of the natural log. Okay, here we go. So remember when we had f of x equals the natural log of x. Remember, this is log base e of x. We just do that enough, and it's special enough that we have a special notation. We just do natural log of x. Okay, so if that was our function, in our derivative unit, chapter 5, we found that the derivative of the natural log of x is 1 over x. Okay, now this gives you just about all the clues you need to figure out what the integral of 1 over x is. 1 over x dx. So think about that for a minute. Maybe jot something down and come back. All right. So remember that the integral is the opposite direction from the derivative. So if our function is 1 over x, taking the derivative goes this direction. So the integral of 1 over x is the natural log of x. Now there's one thing we have to do here, and that's put absolute values around our x. So this is the first rule we're getting with integrals and natural logs. Actually, there's a little more to that. What did I forget? Hopefully, at this point, you're jumping up and down and saying, David, plus c. You always have a plus c when you integrate. All right, so the next one, the related one, is what if we have e to the x dx? So we want to take the integral of e to the x. What's that going to be? Now think about when we took the derivative of e to the x of what we got. And so now you can do the same in this direction. Based on that relationship, you've got your answer here. So when we take the integral of e to the x dx, it's just e to the x. We just have to throw our plus c. Remembered it? Throw our plus c on there. And remember, this is because if f of x is e to the x, then f prime of x is also e to the x. So taking the integral is just going the other direction. But in this case, they're both the same. The only difference is when we take our integral, we've got to throw our unknown constant on the end. Let's do some examples. So our first one, integral of 3 over x dx. Now, we don't have a rule that deals with having a number other than 1 on the top of our x. So you're going to need to do something first to that expression before you can apply one of our integral rules to ultimately solve this. So what I want you to do is pause the video and give this one a shot. All right, let's see how you did. So first off, I have to get this 3 off here. So if I just multiply 3 times 1 over x, that's equivalent to 3 over x. So now I've separated this out, And I have this constant sitting out here. So the rule that we learned last time was that I could take the constant out of the integral sign, like so. So now I have 3 times the integral of 1 over x dx. This is one of our natural log integral rules. So now I have 3 times the natural log of the absolute value of x, don't forget your absolute values, plus c. So that's how to do that problem. Now what I want you to do is take a look at this one. You're going to need to manipulate this expression at first, and then use what you learned about the integral of e to the x and finish that out. All right, let's see what you did. So I realized that I have an e to the x in my equation, so I'm going to need to separate out this divide by 5. So I did 1/5 times e to the x dx. I could take my 1/5 out of the integral sign, and now I have just e to the x dx, and I know from my rule that that's just e to the x. I brought my 1/5 in, and I have my plus c out here. So that's the answer to that one. Now, this one, I'll give you one little hint. Doesn't involve any natural log stuff yet. We're just going to do a warm-up on one of these where we have a little bit more of a complicated integrand. And so there's some simplification that you can do here that's going to help quite a bit. So I wanted to stop part of the way through to give you a little bit of a hint in case you got stuck so you could finish this one off. This is a little bit complex, so I foiled this binomial, and I end up with the integral of 4x to the 4th plus 12x squared plus 9dx. So now you know how to do this one with our addition and subtraction integral rule. So go ahead and do that, and finish it off and come back. Okay, so integrating this one, I just applied my integral power rule on each of these 3 terms separately. Here I showed you my plug-in step in case you're still kind of working that out. Plug-in step for this one, for that one, and then I threw my c on there. And then I simplified and resolved, and I got 4/5 x to the 5th plus 4x to the 3rd plus 9x plus c. So that's the integral of that. Okay, so what's coming is we're going to need to be able to do steps like this before we can apply other rules and other laws. So this whole process of integration is getting more and more algebra heavy. In fact, I would almost say that even though calculus is considered like the next topic from your algebra, that the algebra of calculus is also challenging. 2 more examples, getting a little more complicated. So check this one out. Here we go. We want the integral of 4x squared plus 2x plus 3 over x dx. So go ahead, pause the video, because you're going to have to do stuff to this first before you can even start to apply integration rules. Because we don't have a rule for integrating a quotient like that one. So you might want to flip back through your notes, do some thinking, see if you can set this up in a way that you can then start applying some of your integration rules. Okay, so we don't usually have to do this, but in this case it makes sense. I'm just going to break this up into 3 fractions because I'm going to integrate each fraction a little differently, perhaps with a different rule. So check this one out. 4x squared over x plus 2x over x plus 3 over x dx. So now I can simplify these on down, apply my integration rules, and get to the integral of this expression. So go ahead, pause your video and see how far you can get. Okay, so simplifying down, 4x squared over x is just 4x, 2x over x is just 2, and I left that the same because this is the one that we're going to use the natural log for. So now I can differentiate each term separately. So this one becomes 2x squared. Didn't do my plug-in step. I'm assuming you guys can do that at this point. If you're having trouble working out how this goes to there, you want to pause the video and make sure you can do that. Oops. Got it. Hope you didn't catch it before that. So 2x squared, the integral of 2 becomes 2x, and the integral of 3 over x, it's 3 times the integral of 1 over x, so that becomes 3 times the natural log of the absolute value of x, and I threw my plus c on there, okay? So that's how we did that one. One last problem, perhaps a little bit more tricky. I don't think it's super complicated, but it's really going to test your memory in terms of what an expression like the natural log of e to the 4t really means, what it's asking you. So looks simple. We just have one term, not a whole bunch of terms, not a whole bunch of fractions. It's just one thing. So what we want to do is find the integral of the natural log of e to the 4t dt. So pause the video, see if you can crack that open a little bit. It's actually not very many steps. It's a simple calc, but you have to see something that's maybe not immediately apparent. Okay, so here's the trick. I'm just doing this on the side and then we'll continue on to the problem. The natural log of e to the 4t. What that means is it's log base e of e to the 4t. What that's asking us is what power of e makes e to the 4t. And that's just 4t, because if I want e to the 4t, I have to raise e to the 4t. So this whole thing here is just 4t. Okay? It looks complicated, but there you go. So that changes our problem to this. Okay? So go ahead and pause the video and finish that up. So this is like one of the simplest integrals to take. 4t, applying the integral power rule, gives us 2t squared plus c. So that is the integral of this one. Now, looking at the starting point and the ending point, to me, it's not super intuitive until you've totally mastered how the natural logs and how e work together in derivation and in integration. Now that you've watched the video, take a moment to jot down any additional notes, some questions, or a quick summary of the lesson. You can also re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.